What is up, my physics friends? Today I want to talk about adding vectors, specifically talking about forces. Okay, we talked about adding vectors before, and some recap, you want to add them tip to tail, right? So if you have two in the same direction, say 2 and 2, you're going to have the vector equal to 4. Okay, and if they are in opposite directions, you might have 2 plus -2 equals 0. So forces can work together or they can work against each other. But what I want to focus on today is forces that are at angles to each other. So let's say you had a box and you had one force pulling it in this direction and one force pushing it in this direction. How would the box move? So I think intuitively you know that it's not going to move down and it's not going to move left. It's going to kind of move up and to the right. And the way that we would draw that is we would do the amount to the right, the amount up, notice that I've now drawn them tip to tail, and then the resultant vector would be the hypotenuse between them. And so we could solve r would be equal to the square root of, and I'll call this a and b, a squared plus b squared, right? So we're going to use the Pythagorean Theorem. A squared plus b squared equals c squared, right? So there's my r. It would be like r squared, but then I took the square root. Now, how do I get to a point where I have two vectors? And you've got some practice problems where you're looking at things that it's not just one to the left and one straight up and down. They're at funky angles like this. I've got something like this and one of these, right? And they're at all these crazy angles, and the question is, how does this object move? So the idea, and this is kind of the overall most important thing, is you need to take each vector, split it into x components, and then add up all the x components. You'll see that I like to set it up like this, where I set up all the x components and then I kind of sum them, and when I'm done, I've got a single x value, and then I do the same thing in the y component. I'll have a few different vector components there, and I'll get one final y. And then, I don't know, say this is 5 newtons and 2 newtons, and then I go, okay, so positive 5 to the right and positive 2 up, and now I can do my resultant, a squared plus b squared equals c squared. So the end game here, again, is to come up with a single x value and a single y value so I can use the Pythagorean theorem to solve for my total net force. So I can take all these multiple forces at different angles and just say, well, what does the thing actually do? What's the resulting net force if I had to distill all these into one? Now let's look a little bit deeper at this whole idea of breaking it into a bunch of x's and y's. So again, let's just pick a couple here. Let's say we've got one force that is up and to the right at, I don't know, 43 degrees. And it's 5 Newton force. To break a angled vector into its components, we want to remember that we've got an adjacent side here. In this case, that's my x. And an opposite side here, which is my y, right? And I've got an angle theta. I said it was going to be 43 degrees. So if I look, right, the sine of my angle is equal to the opposite side divided by the hypotenuse. And now if I start putting in numbers, I know this angle and I know the length of the hypotenuse. So I can rearrange this, kind of multiply both sides by h, right? And this h will cancel out. And I get my hypotenuse times the sine of theta equals the opposite side, which is the y value of that component. So in this case, that's going to be 5, the original force, times the sine of 30, and that's going to be equal to 1 of my y components. Sorry, I said 30, it should be 43. I'm going to do a similar thing for my x component. I'm going to use cosine instead, though, because for an x value, right, this is the adjacent sine, and cosine uses the adjacent and the hypotenuse, right? So that's where the cosine comes from. So now I've got two components, and what I like to label these, and you'll see this on answer keys that I make, this is going to be, like if this is the first force I'm dealing with it, I call it F1, right, and then I write x or y. Oh, sorry, that's actually y. and then this is my F1 in the x, right? And then when I start to make my answers, I'm going to have, right, positive 3.7 in the x and positive 3.4 in the y. And that's my first component. And I might go on and have another force. Force number 2 in the x direction, and that might be that might be an up and to the left kind of force, in which case the x value is going to be negative. So maybe it's negative 2 newtons. So now my net force in the x direction is 3.7 minus 2, so it's going to be 1.7 newtons in the positive x direction, right? So because there's more x to the right than there is to the left, I end up with a positive x value. And my forces in the y direction, I'll also add them up, and I'll get some net force. And then I can do a squared plus b squared equals c squared. So, in summary, we're going to look at each force. Let's say there's 3, right? And for each force, I'm going to have an x value and a y value. So this one has 3 forces. This force number 1 is going to have a positive x value because it's to the right. This force number 2 is going to have a negative x value because it's to the left. And this force number 3 down here, it doesn't have any x value because it's straight up and down. And I'm going to do the same thing in the y. Remember, all these x's we're going to be using cosine because as long as the angle's like that. And then over here in the y direction, number 1 is a positive y. Number 2 is also a positive y. They're both up. But number 3 is straight down. That's going to be a negative y value. And I'm going to add them up, and I'm going to get 2 numbers. 1 in the x, right? These are my net forces in the x, and my net force in the y. And then I'm going to have an x, and I'm going to have a y, and I'm going to find the resultant force. Check that out. See if it helps, and let me know. Good luck.